Here next in this unit we completed this chapter: conditional execution, iteration, routines, exceptions, pattern matching, non-determinism and backtracking, event driven computations, concurrent computations. Here this first chapter is completed. Next chapter, second chapter, we are having support of modularity. Next, language features for programming in the large. Here next topic is the in this support. Here concept of modularity. In this topic we are having this topic: interface and implementation. Already we complete the about encapsulation. Here next topic is the interface and implementation. Here in this interface and implementation, here the module encapsulates a set of entities and it provides access to some of those entities here. Here the available entities are said to be exported by the module. Here each of these exported entities, it is available through an interface. Here the collection of the interfaces of the exported entities from the form the module interface. Means here what is meant by the module interface means the collection of interfaces of the exported entities. It is from the module interface. Here next point is the clients request the services. It is provided by the module by using the modules interface. Here which describes the implementation, which describes the modification here. In this interface we are having the module. It encapsulates the set of entities and it provides the sum of those entities. Here it is available that entities, it is exported by that module. Here in this exported, each of these exported entities is available through an interface. Here the collection of interfaces of the exported entities from the module interface. Here next point is the clients request the services provided by the module. Here by using that module's interface, it describes the some modifications. Here next point here the interface, it specifies the syntax of service request. Here in this interface, some languages also support to require the specification of interface semantic requirements. Here some languages also support or require the specification of the interface semantic requirements. Here for this interface is all that the client needs to know about the provider's unit. Here the interface is all that the client needs to know about the provider's unit. Next point is the here some of the problems here. For this problem, it imposes several instructions. Here we are having severe instructions on the solution strategy. These are the following key requirements. First point is the system has to function correctly. Here in this we are having some of the assignment statements. In this such assignment to the wrong pointer, it lead to losing a reservation list. or here interchanging the two different lists and extremely costly here. Here next point is the we have correctness of the system, virtually any cost of the tolerated here. Here next point is the system is long lived. The cost associated with producing such a system is so high that it is not practical to replace it with a totally the cost will have the time. We have a expected that the cost will be the time. Next these are the here these are the key requirements of the strategy and a following requirements. Here next, the system is long lived. Here the cost associated with producing such a system is so high. Here it is not practical to replace it with a totally new features of the time. Next here in this during its lifetime the system undergoes the considerable modification. Here for this example, because of completely we are having some of the regulations you have to change by the required in price structure, and a new type of aeroplane must be added here, and so on. Here other changes must be might be considered because experience is that with the system has uncovered new requirements. Here for this the purpose of the interface is to group together the program components that combine to provide a service and to make only the respectable aspects to the clients here. Here in this module it is clearly described by the two types here, specification and information hiding. Here specification, here in this a program unit provides a service that may be used by the other parts of the program. It is called as the clients of the service. Here the unit is said to be the interface and implementation of that service. Here the purpose of this interface, it is a group put together the program components that combine to provide a service and to make the importance of the information. Next, here we take in last class we take some example. What is the example means here? In this example, airplane reservation for this in this during its lifetime the system undergoes some of the considerable modification here. Here last example, before we completely the new government regulations, it changes might be required in price structure and a new type of aeroplane it might be added, and other changes it might be considered because with the system has uncovered new requirements. It is desirable to have the system of the automatically by trying the system. Next, Next point is that here because of this magnitude of the problem, here many people, tens or hundreds, these are involved development of the system here. Here the client of the service, the separation of the interface from the implementation to the independent of the client and servers from one another. Here a service provider exports a set of entities to its client. Here a client module imports those entities to be able to the survey of the producers of the provider module. Here this because of this magnitude of the problem, many people, tens or hundreds, these are involved to the development of the system. Here the client and server, the client, they have to separate of the interface from the implementation. It is contributes to the independent of the client and server from one another. Here a service provider, it exports a set of entities to its clients. Here a client module imports those entities to be able to the server provides the module. Next it is designed to composed of the highly dependent modules. Here it supports the requirements of large programs. Here next point is the independent modules from the basis of work assignment to individual team members. Here the more independent the modules are, more independently the team members can proceed in the work here. Next, the correctness of the entire system may be based on the correctness of the individual modules. Here the work independent of the modules are more easily the correctness of the individual modules may be established here. Next here the software, it is find out the here for example we take here some languages allow a type to be exported and others do not. Here we are having procedure or function interface. Some languages allow a type to be the exported. Some languages allow a type to be exported and other languages are not allowed to be exported here. Here we are using the procedure or function. Here in this procedure or function, in this we declare this function like this: int max, int x, comma int y. We taking here x is the pointer variable. It takes the address of the another variable, and next maximum of y. It takes the it is a variable. It contains the address of the another variable. Next, it specifies to the clients that the function maximum means maximum here may be called by passing it to integers. Here this function will return an integer result. Here we introduced a name nature to refer the output for a procedure. Here by using this function declaration int max or max, int x comma int y, it specifies the clients that the function max may be called by the passing it to its integers. Here next point here, the specification describes here. The specification describes how the services provided by the module can be accessed by the clients here. Here the implementation describes the module internal secrets provide the specified services. Here next, the purpose of this interface, we are having internal structure of the dictionary unit, it is in the hidden from the clients, here by making the clients only those parts of the dictionary that they need to know how we are having the important properties. Here the client is simplified. Clients do not need to know how the unit works in order to be able to use it. Here next point is the service implementation is independent of clients to be modified without affecting the clients. Here we are having different languages. These languages provide the different facilities. In C language, a file is a unit of this interface. The entity is declared on the head of a file here. Now these are visible the functions in that file. Here the declaration of the function of other files if those functions choose to declare them, and the declaration like this int max of int ampersand x of x comma int ampersand y. Next, here in this implementation we are having procedure signatures form the basis of type checking across procedures. Here in the above code int max, like that, here the name of the function max is intended to convey something about the semantics of the function. Semantics means here meaning of that function, means namely that the integer it will return is the maximum of the two integer input parameters. Here in C++, where the unit of encapsulation is a class, here the interface to the class consists of the interfaces of all the member functions of the class. Here with any other variables of that are available in C++. Here next point is here we have to describe we have to describe in this abstractions allow us to understand, to analyze the problem here by concentrating the important aspects here. Here in this modularity allows us to design and build the program from smaller pieces, that is called here modules. Here during the problem analysis we discover and invent abstractions and allow us to understand the problem here. Here during program design and implementation we try to discover a modular structure of the program. Here if modules that implement the program closely to abstractions, and it is discovered during the problem analysis. Here the problem will be easier to understand and manage here. Here the principles of the modularity and abstraction here help us to apply the problem solving strategy. That strategy is called as the divide and conquer. Here the concept of a large program is defined precisely. Precisely means here clear. We do not want to equate the size of a program, means here example number of the sources of the statements. Here next we are having largeness relates more to the size and complexity of the program. It is solved by the final size of a program. Next here during the program design implementation we try to discover a modular structure of the program here. Next here in ADA programming language, the interface and implementation, it treats the separation of interface and implementation. Here in ADA programming language, the unit of encapsulation is a package. Here in package the the encapsulates a set of entities, encapsulates set of entities such as procedures, functions, variables and types. Here the package interface, it consists of the interfaces provided by the each of those entities here. Here the ADA package supports the encapsulation by requiring the interface of the package. It is called package specification. It is called package specification. Here in this package specification we discovered to be declared here, to be declared here. Here in the ADA package, here in the ADA package it supports the encapsulation of requiring the interface of the package here. This is called the package specification to be declared, and implementation of the ADA language. Here next point is the here the specification describes the how the services provided by the module can be accessed by the clients here. Here the implementation describes the module we are having some of the specified services. Here next point is making visible to clients and those parts of the dictionary that they need to know, and we have to achieve, we are having some of the important properties. Here first property is the client is simplified. Client do not need to know how the until bugs in order to be able, and next point is the service implementation is independent of clients and may be modified without affecting the clients. Here in ADA programming language we are using the encapsulation is a package here. In the package encapsulation is a set of entities such as procedures, functions, variables and types. Here this package interface consists of the interface provided by each of those entities. Here in this ADA package it supports the encapsulation by requiring the interface of a package. It is called the package specification to be declared and the implementation of the ADA. Next here the package body contains all the implementation details that are hidden from the clients, Here there are some differences between the packages of ADA and classes of C++. Here even though this simple example, here we can see the difference between the models supported by C++ and ADA. Here in C++ the client can declare several instances of the dictionary class. Here in C++ the client can declare the several instances of the dictionary class. Here in ADA programming language of the module may be the dictionary class. Here in C++ the client can declare several instances of the dictionary class. Here even though from the simple example we are having the difference between the models supported by the C++ and ADA. Here in C++ the client can declare several instances of the dictionary class. Next this is the example package dictionary is procedure insert C string I integer. C is the string and I is the integer. Next function lookup, you have to use the lookup function. C string integer procedure. Next remove C string and dictionary. This is the in ADA we have to use the code like this. Package we are using the in C++, in ADA we are using the package here. The package, this is the client can declare several instances of the dictionary class. In ADA programming language, the client can declare the module. Next, here this is the simple example for the package dictionary is procedure insert C string I integer, next function lookup C string integer procedure, next remove function here lookup C in string integer semicolon, next procedure, in this procedure we have to remove C string and dictionary. Next, this is the another example ma. Here the package body dictionary is type node, type node pointer is access node, type node is record. Here we give the name string, id is integer, next equal node pointer. Here have to end that record, give the root node, here node pointer. Here you have to insert the you have to insert procedure insert C string I integer is begin implementation and insert. Here the function lookup string integer is begins with the implementation, you have to end lookup, next procedure remove. We are using these functions, these procedures insert, lookup and remove. C string is begin with implementation. Here this is the example for that. Package body dictionary is type node pointer is access node, type node is record, collection of files is called a record. Here name in that string, name it is defined in the string, id means it defines in the integer, next node, next variable contains the node pointer and record root node pointer. Type, next you have to use the another procedure insert. Here you have to end this record and next root node pointer. Next you have to write procedure insert C string I integer is begin implement. You have to do the implementation, have to end insert function. Here next function lookup C string integer is begin. Next in that implementation we are having lookup, you have to end lookup. Next in this procedure you have to remove C string is begin. Here implementation and remove. Next topic is the how to separate and independent compilation. Here first point is the idea of modularity is to enable the construction of large programs out of smaller parts. These are developed independently only. Here the idea of modularity is to enable the construction of large programs out of smaller programs that are developed independently. Here at the implementation level, independent development of modules that they are compiled and tested individually. That may be compiled and tested individually. Next, independently of the rest of the program. Here it is referred to as independent compilation. Here the term separate compilation is used to refer to the ability to compile units individually. Here but we are having the constraints. Here this is the idea of the modularity. It is to enable the construction of large programs out of smaller parts that are developed independently. Next, at the implementation level, dependent level of the modules, it implies that they may be compiled and tested individually or independently of the rest of the program. Next, for example, here C supports independent compilation and ADA supports separate compilation. Here, for example, you take in C programming language supports the independent compilation, and ADA programming language supports the separate compilation. Here in ADA we will see later some units may not be compiled here until other units have been compiled. Here the ordering is imposed to allow checking of inter-unit references. With independent compilation, there is no static checking of entities imported by a module. Here with independent compilation, normally there is no static checking of entities. It is imported by a module. Next, here for example, we are having C supports independent compilation and ADA supports separate compilation. In ADA programming language, here some units may not be compiled until other units have been compiled. Here the ordering is to allow checking of inter-unit references. Here for this purpose we are having separate and independent compilation. This is referred to as independent compilation. Means you have to compile and test individually. At the implementation level, independent development of modules that they may be compiled and tested individually, independently of the rest of the program. Means the idea of this modularity to enable the construction of large programs out of the smaller parts that are developed independently. Next, at this implementation level, independent development of modules, it implies that the compiled and tested individually, independently of the rest of the program. Here it is referred to as the independent compilation. Next, with the independent compilation, there is no static checking of entities. It is imported by a module.